Good evening, Twitch. Hello, everyone. That was perfectly timed with the music, but not intended. If you're here, let me know by writing in the chat where you are watching from today. I would like to know where everybody is watching from. It's currently just past 9 p.m. here in Zurich, Switzerland. That's where I am based from. My name is Maddie, or Maddie Two Shoes, formerly known as Matthew, and today we are going back to the movies. If you were not on stream, didn't have a chance to join my stream on Saturday, or you haven't watched that VOD, it's still up on Twitch. We were playing around with an IMDB extract that IMDB actually provides on their website. So that was a really great data set to find, and I thought I would spend a little bit more time working on that today as well. So I do have the wrong screen up because actually the stream has started. So let's dive right in to what we're going to be looking at today. So I should do the trailer voice thing, but I don't do it very well. You know, previously on SQL at the movies. But yeah, we found out a couple things. We found out that much to my girlfriend's discontent, horror is the lowest rated genre on IMDb. We had a lengthy discussion about that on the weekend after the stream. It didn't surprise her, but of course it's not something you'd like to hear, right? She's quite a horror aficionado. I guess there are reasons for certain categories being that way, and so one of the things that I wrote down that I might want to look at is if there's a link between the number of votes and the rating of a movie. Like if the movie gets more votes, is it more likely to be a good or bad rating? Good being, well, that's something we can maybe figure out as well. That would actually be a cool thing to do, is maybe devise a breakdown of ratings, or can we classify ratings into good, average, bad? Something we could also look at. Do the number of actors in a movie make it better rated? Not necessarily whether the movie is better, but better rated. What actors, actresses have the best ratings? What directors or writers have the best ratings? This is quite a fun one to think about. It's something we didn't do last time yet. Is there a link between the number of votes and rating of a movie? So correlation, causation. I'll mention this again because I do mention it every time. If we discover correlations, it doesn't mean that one of those things caused the other, but there is a link. How we explain that link or how we determine if that link is relevant is a different question. We'd have to do some sort of maybe regression analysis or something like that, which I'm not experienced enough to be able to do that kind of thing, at least live on stream, to be able to be confident enough to show you how to do those things yourself. So I refrain from doing that. Is Die Hard still the best movie? It's more of a joke question. It was in there last time. I decided to leave it in. The data we got from IMDb, just to say again, I'm going to pop that in the chat. Very, very cool that IMDb provides that data for us. The data quality is very good. We spent a good amount of time last stream going through data quality. And so this time we'll be focused really on just the analytical questions that we have. What's in the data set? We can actually jump directly into DataGrip to take a look at what we have. So DataGrip from JetBrains is the IDE I'm using. All my details are in my profile on Twitch on my About. You can take a look at what my setup is. I'm using Postgres database. It's running on Docker. And I also have some nifty stuff set up for visualizing data as well, if we would like to do that. Also a possibility. But for the moment, we are content with doing it this way. So if you're watching, let me know if you have questions. Let me know if there's something specific you'd like to see. But I'm just gonna continue with my questions and see what I can find out. So I typically like to write my question up here. And the first question that I wanted to tackle was actually about the classification. So can we classify ratings in good, average, bad? That's one thing that we should maybe do. So I'm going to borrow some queries that I wrote previously because it doesn't make sense to rewrite everything. So if I'm going to reopen here, this is a nice little data frame that we had from last time. So this was a classification of all the titles and the joined everything together here to the ratings and the genres. So this is good. We can actually use that. So let's copy this and put this down here. And I'm going to get rid of the selects. I don't need to do any ranking right now. There is a possibility, of course, to do ranking, but let's see. All right, so this is, just to maybe see the data set again. So this is like the basics table that we're looking at. So, it's got like a type of title that it is. It's basically these titles in IMDB are everything. Movies, shorts, even audio stuff. And they have all these genres in there, which we split out into title genres. And we use the tconst as the key between those. So we got primary title, the original title, in case maybe it's different for some reason. We have an adult flag. Didn't do anything with the adult stuff. Don't want to get banned, so probably won't. Runtime in minutes. We could do something with runtime as well. Whether the runtime affects the rating, that's maybe something to write down as well in my list here. So yeah, does the runtime of a movie affect its rating? That's something we could also look at. But yeah, I mean, this is good for now. So I don't really care about the years anymore for now. I don't care about the release year. So I'm just taking the key. Oh, yeah, that doesn't work so well actually, I discovered. Moving the lines doesn't always work so well. So let's see here. So what have we got? That's from last time. We can get rid of this. So we select the ID of the title, the average rating, and the primary title. where the title is a movie and the start year is known. We're going to take out the genres for the moment. Not relevant. And the average rating is not null. That's fine. Do we need this? Probably not. Okay. So how would we classify ratings? So let's make this into a common table expression first. So this is our data frame. I could have kept this in actually. Oh wow, Sharpclaw! You've decided to raid. Welcome, raiders. I'm not able to do my stream in Russian though. I hope that's not a problem. I was just about to dive into these movie ratings. If we can actually put each title into these buckets. So the first thing we're looking at is creating the buckets themselves. So let's see what our data set looks like. So we have basically every title, its average rating, and that's it, which is fine. But now we have to get these ratings, and we have to determine where they are in the data set. There's a couple different ways we could do this. I mean, let's see. So tconst. So if we do select average rating, I think we're just gonna do first, let's find the spread of the average rating. So count distinct tconst, number of titles. Definitely have to group here. Almost forgot that. I always mess up descending and ascending order. Never know which one is which. Alright, so we have... Wow, that's not a lot. These are all the ratings. It's a bit hard to visualize the spread. So let's take this into our metabase actually, because we could then just visualize it pretty easily. Is that a raid I see incoming, Sharpclaw? Is that possible? I think I got a notification that you're raiding me. So if you're here, do let me know. That would be great. Maybe it's a mistake from Twitch. Thank you, Graceful. I'm trying to understand what you do. Well, let me summarize for you. I have a data set from IMDB with the International Movie Database. I think it's called the official title. And basically, our Internet Movie Database. And we have a data set of all these different titles, and we did some exploration last time about what movies are good, what movies are bad. We found out that horror movies are the lowest rated on IMDb. And today I was curious about a few other things. So I can just show you some of the questions about, can we classify ratings in good, average, bad? Can we figure out if the number of actors in a movie make it better rated? I mean, these are all correlations, of course, but we can at least look at the patterns. What actors, actresses have the best ratings, for example. What directors have the best ratings. I'm sure that some people have some assumptions or ideas about what directors could have the best rated movies under their belts. Is there a link between number of votes and the rating of a movie? So this is like an IMDb specific question. But yeah, right now I just wanted to understand the spread of the ratings. And for that, we can just do x-axis average rating, y-axis number of titles. So this is a very, very simple histogram, but it tells me everything that I need to know about my data set. So like, this is a pretty classic example, but it's not a perfect bell curve. So perfect would be slightly here to the left, but basically all the titles are hovering around this 6 to 7 area. Which is, it's not really that surprising. I guess most movies are like a 6.5, right? But what does that mean for our scale, right? Because we could scale everything to just, we could come up with our own definition of what is good and what is bad. But it wouldn't be relative to the spread of the movies here. As you can see, there's 6.5, there's 8,472 movies that were rated average of 6.5. So we have to, let's see, maybe we need to come up with our own definition. We could do our own first. So for example, we can do a simple case when. So when the average rating is greater than 0. Oh, let's do between 0 and 5. Then let's call it low. Oops, sorry about that. Then we have the next one and the next one. So we have a rating between 6. So this is up to 5.9 actually, so we need to adjust that. These numbers are inclusive. Between 5 and 7 is like average. And between 8 and 10, then high. Hello. And then we call this else unranked. The between does include the limits, yeah. It's inclusive. It depends a little bit on how your data is formatted as well, but it is inclusive, yes. So and we're gonna call this the average group. It's a terrible name. Let's call it rating group. That seems better. Oh, I don't like this formatting at all today. It's not cooperating. 1, 2, 3. Yeah, whatever. Something like this. So now we'll be able to visualize this here. We won't need Metabase. No problem, Devo. As I said before, if you have questions, feel free to ask. That's kind of the point of Twitch, right? So we have 71,000 unranked titles. So DevTori says, can I use exclude between? So basically outer conditions. Not not sure how I would write that. I would probably do something like greater than and equals to, because it's a little bit easier to, oh my gosh. I will get it eventually. There we go. I will do like greater than 0, and the problem is that you need to write the terms out twice. You need to write the dimensions twice. Yep, this is JetBrains data grip. You are correct, Dinceptor. So I have all the details of my setup in the about in my Twitch profile, but I'm running the Postgres database. I'm running in a Docker instance to make it a little bit easier to manage, because I can just shut it down when I don't need it. So Devotori was saying there's a few different ways you could write these conditions. So average rating greater than 0 and average rating, for example, less than 5. I could steer this more accurately. But this is pretty interesting because there's a lot of unranked. I'm not sure what those titles are. So Devotori says, so I'm sure you can use 0 smaller than x smaller than 4 for exclude limits, but between has a condition for this. I'm not sure I quite understand your question, or maybe I don't know what you're talking about with between. So between is always 2 integers, but in this case the integers are inclusive. It could be that if it's like 7.9 that it's not including it. It's a bit weird. So what we can do here to debug this, we're going to just call this debug as. It's the easiest way to figure it out. Is basically, instead of counting here, we just comment this out, put in my tconst, which is the ID of my title, do a select star from debug. Oh, this is not cooperating. Oh, it doesn't like this name. It's not a friendly name. Yeah, sorry, Devotori, I didn't quite understand what you meant, but it's probably my understanding and not you asking, just to be clear. So yeah, this debug window, we have a tconst, and then we just do from where debug, where rating group equals unranked, and then limit 10 or something. Oh yeah, forgot about the group by. So we had the group by in there this time, but oh, we need the rating too, don't we? Forgot that. So we just execute this again. So we have 7.1. Wow. Oh, Dinceptor, thank you for the follow. It's very appreciated. That way you'll be notified next time that I'm streaming. I try to stream once or twice a week. Mondays is pretty regular. The other one is relatively spontaneous. Last time was a Saturday. The other time was a Friday. Depends on what kind of daily business I've got going on with my work. So, yeah, but I appreciate the follow a lot. Thank you. So it's inclusive, but it's not catching everything above 7. So now we know that we need to write them a little bit differently. So what it's doing is it's not catching the values that are between 7 and 8. That's the problem. So we actually have to overlap the numbers. I probably should have known that, because I've had that problem before. But basically, if we want an even spread between 10, obviously we'd have to do 3.3, but I'm deliberately not doing that kind of classification. I'm doing my own. That's the first way that we can do this, right? We can make our own classification. So let's say between 0 and 4. Between 4 seems a bit low. Let's do 5. Between 5 and 8 and 10. This is like that. Then we can get rid of this stuff. We don't need it anymore. Put back our count. Put back our group by. and get rid of the wrapping condition. And then remove this comma. There we go. All right, so we have our distribution here. We have 49,000 lows, 14,000 highs, and 193,000 averages. So we see this is like the curve that we saw before. Let me just bring that up again. It's like this curve we saw before, but obviously numerically here, and now in this we've just we've just put it into a category. And we could make different categories. We could have 5 categories, but the problem with this is that mathematically speaking, we haven't actually considered the spread of the numbers. We've just actually kind of defined arbitrary boundaries, which I don't think is really cool, to be honest, because I would want to have something else than arbitrary boundary. I don't think we're learning so much from this data set by doing it this way, because we can basically learn the same thing that we saw before in the chart. So, what are some ways of doing mathematical boundaries? We can actually do basically percentiles. So, what is a percentile? A percentile basically means where is the value distributed. So Graceful Potato says, are you talking about 0, 5, 8, 10? Yes. So this system that we used here is kind of arbitrary. I've just made a decision and said 0 to 5 is low and 5 to 8 is average. But I want the data to decide. You know, that's kind of the whole point in collecting really cool data, is that we can let it speak for itself, and we can actually cluster these into their own groups. And so one way of doing that is using what's called a percentile distribution. So it's a value between 0 and 1. And that looks basically something like this. So I'll just keep this in here for the moment. This is our own rating group, right? If we do percentile disk, this is the function we'll be using to get a percentile of the values. Now, we need to do this in the raw data. So I need to do it up here. So percentile disk is basically the function that we're using. And the way that this function works is we do percentile disk 0.25, for example, within, and then group. And now we have to decide how we're going to order the group. And of course, we're going to order by average rating, ascending, I believe. So this is, let's call this percent 25. So this is like the 25th percentile. Oh yeah, because we have a calculation here now. So these are dimensions, and now we've done an aggregation or calculation. We need to actually add the group by statement. That's going to be at the end here. Group by 1, 2, and 3. This is basically referencing 1, 2, and 3. That's a nice thing about some SQL languages allow you to do this, which is very cool. So, oh, I didn't want to execute the whole thing. Sorry about that. Stop. We just want to look at what this spits out. So you see here, if I haven't grouped the values yet, it just spits out the same thing again, right? But if I start to put this into a grouping that I already have, for example, here, then I can put like this, and I can group by 1, 2. We can take the group by back out of here, and I think this should work. Oh yeah, we just need to group by 1. So you can see it's actually told me now where these boundaries are. Does that make sense? I basically have, let me just organize this a bit better. It's the problem with using names. Come on. So I have 3 groups that I made. And these groups are based on arbitrary values, let's call them. But what's interesting is that it's able to tell me where the percentiles are. And now, so if you want to know something mathematically speaking, the median is usually the 50th percentile. So if I were to call, instead of the 25th, if I were to take now the perc 50, so 0.5, I could basically call this median. I could calculate the median as well, but let's just leave that for the moment. It's not really worth doing that. So you see here, I would start to see a spread of how each of these values are spread. So I could also do the same, for example, for the 75th percentile. So this is, I don't know if it's the median 100%, so I'm just going to rename this back to 50. So now we have the range of each of these. So we have the 25th percentile, the 50th, and the 75th percentile. These are the boundaries of the specific data sets that I've selected. Now, if we wanted to have boundaries set for us, so that means I need to find out where each value lies in the data set, then I would need to create a group of all the values, most probably. Let me think about this. All right, Devotori, good night. Yes, it is 9:30 here, almost 9:40. Thank you for joining today. Hope to see you next time. So I think in order to get the percentile values... Oh, and thank you for the follow, Devotori. Appreciate it. So we will have to calculate all the percentiles. Let's see. Just reading a little article on the side here about generating percentiles for an entire data set. But I don't want to do that for the entire data set because it will be very slow. So let's see. So what I'm looking at, if I just want to share this with you guys. Looking at this article here about calculating a percentile. I'm gonna just open this up. So what we can do is we can actually generate a series. I don't know if you're familiar with this function. We can generate a series that populates all the values from 0 to 1 in increments of 0.01, which is very helpful because then we don't need to write out every single percentile. And then we would, using that, tile the data, so tile our titles data set with the ratings into a bucket. And we specify how many buckets there are, and there's 100 buckets in this case. So it returns all of our values with each bucket, and then we interpret these buckets into percentile values. So this is what I'm going to try and do with the data set. So I probably won't look at chat for a minute or two while I focus on doing that. So let's see if we can get that done. So we need to generate the series. Just gonna take this over. That's fine. Let's get our series up and running. So that's the data frame. I'll need that afterwards. Let's call this series. Oh, I see. He did the generate series directly out of the initial select. That's very cool, actually. I quite like that. So basically, K, percentile distribution K. It's very interesting. So let's look at that. We could do that. We could definitely do that. We have the average rating. We don't need the title in this circumstance, actually. So we'll have... This is pretty cool. So percentile distribution of the average rating within group order by... Did he just assume? Oh, I see. He actually just made a variable, basically. Okay, let's continue here. So I spend a lot of time learning these types of things, and this is a situation where this is something I haven't done a lot. So that's why I'm following this guide, which I found to be very good, actually. This particular, I think it's a blog. Yeah, this is, so bear with me while I run through this, but I use the stream as an opportunity to also learn for myself. I don't know everything, obviously, so I try to learn things as I go along as well. Don't want to just be doing things on stream that I already know how to do. There's getting out of your comfort zone, I think, is very important for improving and continuous learning, which I believe in. So the question we asked ourselves about, can we classify ratings in good, average, bad? That was a little bit misleading about how simple this seems, but it's actually not that straightforward, right? So we have our table, which is title basics. So we're gonna, I see what he's done. Yeah, I understand now. Now I understand. So we're gonna do like this, order by average rating. Now it just clicked. So what we have here is a from title basics, and we also have a generate series as K. Also let me know if music is too quiet, too loud today. Decided to put on something different than vocal trance. Don't know if Sharpclaw's audience appreciates that, because she was probably running some electronic stuff. So let's see. Percentile disk, generate series as K. That's right. That generates table between 0 and 1, or 0.01 and 1, because we can't have 0, and in increments of 0.01, which I know. You can use generate series for dates, for example. That's something I'm gonna look at in the future, a time series data set where we don't have all the dates available to us. That's a very useful function for doing that. It's just creating a set of dates, or yeah, like a set of hours or times or whatever that you need, and you can specify the increments and everything, so that's really cool. So now we have, if we look at this, this actually should be working. Oh, invalid reference to from clause for table TBA. Why is that not working? Oh, maybe because the reference here. Let's see. There's an entry for table TBA, but it can't be referenced from this part of the query. So what we could do is take this part out. We could say, so we say with titles, take out the rating. Oh, we need the ratings to sort them. That's not a possibility. Let's see what the issue is here. So it doesn't like the reference of TBA. Need to see. So the problem is K. Let's try a cross join. So let's make a generate series before this. Generate. So this is a series, comma. We need comma after each common table expression so that we tell the code that's being executed where to look and what order it's in, right? Select star from, oops, data frame. So we have comma, data frame, cross join. What did we call this? Series? This basically just adds it to the data set. So I don't know if this is gonna work. Yeah. Maybe it was just a group by issue? Is that possible? Oh, maybe it was just an issue that we hadn't grouped by yet. Series K must appear in the group by clause. Ah. Okay. Yeah, this is not the way to do it. Definitely not. If we just generate the series directly here, then we shouldn't run into this issue. Oh, I don't understand this issue here about TBA. Let's try and debug that. Might need to do the left joins later, but we need the ratings. Okay, let's take only one for now, because we're not doing anything with the genres. Invalid reference to from clause entry for table TBA. Oh, because there's two aliases. I think that's the issue. I think that's the issue. Let's see if this fixes it. But how is it gonna know? I think we need the reference. Multiple from tables. Just checking here about aliases. Whether I can see if multiple aliases. It should not be an issue. It should be like A, B basically. It should be no problem. That's what I don't understand is causing the issue. So the generate series function, graceful potato, asks if we can join it. The problem is we have no key for the generate series function. In order to create a join between two tables, you need to have a key in order to join on. We don't have that. So that is the reason that we can't join them in a classical way. That's why I would basically just have... So let me show you what this generate series looks like. This is basically what it looks like. It's every value from 0.01 to 1 in increments of 0.01. So there's 100. As you can see here, 100 rows. So generating this, if I comment out average rating, maybe I can't include the average rating. Column average rating does not, yeah, so it has some kind of issue with the from clause entry. Okay. Need to look at this again here. Blah blah blah. Percentile blah blah blah. Definitely need to.
Original ganja we smoke it, and a real time dub assassin sound with the Krypton Industries and the real life bass music.
Dubs. Is that a timetable? Well, get on it. It's your time.
So now that we've sorted out the music a little bit, so if we have a table called things with a column called value, so this is our thing and this is our value, which is fine. Maybe we need to actually have it joined before we do this. So we'll just have to do it in 2 steps, as you said, Graceful Potato. We'll just have to do this in 2 steps. So what we'll do is we'll do our joining work, everything here. So the average rating, blah, blah, blah. Let me just pop this down here. So we're still going to do select star from data frame. We're going to want to have this in addition. So we'll do like that. So this is called df. That's great. And now we take that out and comma generate series. I don't know, we'll call this generate series GS. Let's see if this works. So that's wrong. So common table expression is here. Formatting is important so we can read it properly. This executes probably no problem. We don't even need the group by anymore. We should have all the titles with the ratings. Wonderful. I mean average ratings. As I explained last time, they are averages that were downloaded Saturday morning. So obviously the averages change over time as people vote, but that's just the snapshot that we're dealing with from Saturday morning, which I assume includes up till like Friday lunchtime. So if we execute this, we should get, we need to group by. So we have in our original data set here, we have 2 dimensions, and now we have an aggregate. GSGS must appear in the group by clause or be used in an aggregate function. That's interesting. Okay, this is some weird music today. So, can you even hear this? It's a very quiet track. I don't want it to explode in your ears, so that's what I thought. All right, so GS itself has to appear in a group by. That's weird. Why does it want us to do that? Okay. I'll have to think about that afterwards, why it wants us to group. Graceful Potato says, could you explain within group statement? I never saw it before. So the within group, this is a relatively easy explanation. This is called an ordered set aggregate. It basically means it runs an aggregate and then orders it within the same function. There is some documentation about Postgres about that. Maybe I can just link that here. So this is it's a pretty nifty function because it allows something to be grouped and aggregated at the same time. Oh wow. I was a little bit afraid of this. So the problem is it a Postgres specific thing? I don't know if it's specific to Postgres or not. So my computer needs more memory, is what the error says here. What's happening is it's not able to process all the titles. You're welcome, Graceful. I don't think it's specific to Postgres. I think it does exist also within group also. It's just SQL allows. I mean, percentile disk is a Postgres function, but I think similar functions exist, for example, on Redshift, possibly MySQL as well. I'm not sure. Depends on the flavor of the machine, right? Where it's being run. BigQuery might have something like that as well. So coming back to this error, the error is that the query cannot compute because it's creating these buckets for every value, and our data set is actually too large. So this is actually not going to complete. So one way we can get around this, instead of doing the analysis for the entire data set, is just to do it for one genre, because then the data set is smaller. So let's do it for action, because we saw last time that action had a lot of votes. So let's see if it runs for this one. There's not a lot I'm going to be able to do if it doesn't run, other than creating this table. Oh, there we go. Look at that. Okay, that was great. What happens if I comment this out? Oh, maybe I should actually just take out the genres. That was a big data set. Maybe the genres was causing issues. Oh, and we should have an alias for this as well. What should we call this? Let's see. What was LIFO's recommendation? So all percentiles. Didn't actually name that one. Let's see. Ideally, we want to scan the data only once while keeping track of what percentile a particular value is in. Postgres has a window function that can be used to accomplish this, called entile. So this, that's very interesting. So he runs it, or she runs it in the end, like this. So this was our ranked one, which we don't need, because that was very arbitrary. Let's see here. So the query is still running. That's fairly inefficient, which I understand, but I was trying to do it anyway, just to see if it would do it. We can keep it running in the background. It's just making my machine groan a little bit. So we might want to do something with the genres, so I'll leave those in there. But basically, he didn't do common table expressions, or I don't know if it's he or she. They did a nested subquery, which is fine. So we could call this prep. I'm just a very big fan of common table expressions because I think they're very efficient. Wow, that did some weird formatting. Wow, okay, that's very weird. I don't want it to do that. Just want it to go 1 over. It's more than enough. So we need a comma in there. So then we would do max. I see. Name the entire thing as buckets. That's fine. Let's call it buckets. So select max. Well, we'll get to that in a second. From buckets. So we had the things value. Oh, I see. You didn't even use percentile disk in the end. Oh, that's interesting. So instead of doing this with 100 different ones, that's very interesting. So if you're still hanging on with me, I appreciate it. This is part of the learning process, right? Could do it like this as well. So we have our value, and we could do entile 100 over. I like to use, for my functions, I like to use caps. So the average rating, we want to order by average rating. Well, we already have that from the data set. We don't need to do another from. That's fine. And now we should have max. I don't know, let's call this buckets.value. I'll just call this RS for now. And then entile as, this is called percentile from buckets. So it doesn't like this entile. Why is that? Interesting. Entile 100 is creating. So we have our value. Oh, I see. Right. we can just do percentile like this. Oh, oops. Just like this. And the max buckets.value is basically the average rating. Group by 2, order by 2. I think this should work. I don't know how long it's going to take to run, but this should work. In the meantime, I'm going to take a small drink of water. So if we don't lose focus here on what we're trying to do, basically, instead of choosing boundaries for our ratings, we actually want to see where they lie in terms of percentile distribution. And that allows us to better understand the ratings data set. That's basically the reason. So this is sweating my machine at the moment. I hope that you cannot hear it. Perfect. Wonderful. So this has assigned all of our movies into buckets. And basically the way that it's done this is it's given 100, it's given every single rating this bucket in terms of percentiles. And this is very useful because it allows us to then say where each movie lies. So what we can do with this, what we could do with this is now determine which movies lie in which percentile, but we would get the same distribution as before, right? We would get this beautiful curve. Let me just bring that up again. We would get the same curve because the movies are distributed histogram-wise. They're distributed along the same way, right? Just for illustrative purposes, we could look at that. But what I would do is maybe do this for 2 different genres to compare how the 2 genres are different. So let's say, for example, let's do action. So this would be the action genre. I hope it takes way less time than before because it is a smaller data set. Perfect. So this is the action data set. You can see that the percentile here is 2.2, and then the 50th percentile is 5.8, and the 100th percentile is 10 because the best action movies have a 10 rating, but the lowest one has a 2.2. So we could do this, and we could save this. Basically, if we assume that these are now the percentile values for each one, we could basically map each of the titles back to this. I don't know if my computer will like this, but we could definitely do this. So we have a bucket, we have a percentile, the max average rating and percentile. Instead of doing max average rating, we could do tconst percentile. That would probably work. Oh yeah, because we didn't max. Let me think. Yes, we can count distinct. So we can do it the other way around. We can say percentile, max average rating, and then count distinct of the t-const, and this is number of titles, or movies in our case, because we've already filtered. Group by 1, order by 1. So this is just for action, bearing in mind that we've filtered up here. So genres like action with the percentages, that's because we basically had the situation that genres in the original dataset are separated by commas. Like movies fall into multiple genres. It's not a clean one-to-one classification, it's a one-to-many classification. So here we see the percentile, the max rating, and number of titles. Now you see, this is like the number of titles in each bounds. It tries to get them to be the right amount. It tries to get them equally distributed. That's the idea, right? So we can see here that that's how they're distributed, right? It's not so interesting in terms of, okay, these are the number of titles, because I mean in proportion it's percentage-wise, right? It's the same distribution. It's 1 to 100, so it's 1% per per percent point, right? Per percentile rather. But what we've learned is that for action, we have basically the 25th percentile is 4.9. The 50th, and we could have done this the other way with percent disk, but I just wanted to show that there's another way of doing this. And for whatever reason, if you're doing something differently, you might want to do it this way as well. To assign each title into its percentile, you could do that. Rather than just counting it, you could have each one in the percentile, obviously. And the 50th percentile is 5.8, and the 75th is 6.6. So now we can compare it for a different genre. Feel free to suggest one in the chat. I will just take some water. What genre would you guys like to compare it with? I can tell you what there's available. Select distinct from dot genres. So this is the list. I don't need to order it. I'll just do it like this. So this is the list of genres that we have. Please don't choose adult. We could compare the rating spread to see. Maybe there's something here. Sorry, my Twitch mod view is acting up on me. I'm not sure if someone gave a suggestion. I'm just gonna pick a number with my eyes closed. Thriller. Okay, that sounds good to me. So let's take here Thriller. So we are now going to figure out what the spread is like for the thriller genre. So the thriller genre, the 25th percentile is 4.7, okay? The 50th is 5.7. And the 75th is 6.5. So they're pretty close, these two. They're actually very close together. I would like to do the adult one because I'm really curious about whether they are actually that different. My gut feeling says yes, but oh wow, that query was quick. All right, 25th percentile is a 5. Okay. 50th percentile is 5.8. That's the same. And the 75th is 6.5. So the spread is not so different, actually. The spread is not so different. But what you see is that if we do this for the whole data set, if we do this for every genre, right, then we have basically the even distribution of the data. So if we were to cut this data into 100 slices, equal ones, then the clusters would be, this is how they would be distributed. And that's if we then make a case when statement like we did before, where we said, okay, between 2.8 and 5 is our first cluster, that's our first quantile, basically, as far as I understand correctly and remember correctly. Math is not my strong suit, I might want to add. But that's basically saying, okay, that's our first quarter of the data set. This is how many movies are in there. And that's basically how the data would be evenly distributed, right? We know it's not evenly distributed, but we can see, we saw the occurrence of ratings before in this chart, right? We saw basically where the bulk of the ratings are. So that was kind of a little interesting exploration exercise that we did. This is still running. We can classify, but I think I'm just gonna stop it because it's gonna take a very long time to finish executing. But yeah, basically we could look at like that, and we could calculate some averages, of course, for the whole data set. I don't think that's that interesting, to be honest with you. But yeah, we could definitely do basically, once you have all the films rated, you could break them into these. So once they're evenly distributed, you could, of course, break them into their relative genres and see the spreads across all the genres. But that's, again, I somehow don't think that's so interesting. So one of the other things we wanted to do is look at the number of actresses in a movie and the rating. And for that, we need to change up a lot of stuff. This is cool. I'm going to keep that. But I'm going to start with a fresh query window. Make sure we get our spacing and our font size okay here for you guys to be able to read that. Let's see that this is good enough size. All right. Oh wow, that's already taking a long time. Maybe I'll just limit that. Come on. Oh wow, okay. That's memory issues here. There we go. So we have some stuff from before which is very helpful, which is this data frame. So this is the data we're working with, right? Our data frame is our ID, our average rating, etc. This time we're doing something different. So we need the ratings. We could take out the genres for now. That's not really part of my question. It's a movie, it has a start year. Genres are not that interesting right now. The average rating is not null, because otherwise, yeah, we don't have a rating. What we want to know is the number of actors and the ratings. How do we get number of actors? Well, there is a title crew table, which looks like this. This is directors and this is writers. So this table doesn't do it for us because it doesn't tell us who was acting in a movie. However, we have a name basics table. And here we have an n const. So the t const is the title constant or title ID. And the n constant is the name ID. So the primary name, so for example, if I did primary name equals Bruce Willis, voila. I have two entries for Bruce Willis. One, born in 55, actor, soundtrack producer, known for titles 1, 2, 3, 4, and another one known for one title. So this is not a perfect data set. We have to understand that the data that we're working with is the data that we get from IMDB. It's probably not perfect, as we see, but I think it should be possible to use it. So maybe we could do, I don't know, a like here or something like that. We could check if Bruce Willis appears more than once. No, it seems he's only in here twice. Unfortunately, these are not all his titles. I think there's some limitation that they have in the dataset that you can't re-engineer their entire product, which, to be fair, it makes complete sense, because if I was IMDb, I wouldn't want someone engineering my entire product from the data. And since last time I did a little bit of reading about IMDb, about how they make money with their pro subscription and stuff like that for people in the industry, and they have access to special data and stuff like that. So yeah, I understand that not all the links are going to be here. But if we assume that they've done it the same way, then yeah, we could assume that they've made a cutoff for some reason. And that cutoff should be the same for all users, I would hope, let's say. So yeah. If you've made it this far, congratulations. Appreciate you spending time watching my stream. I'm playing around a lot today, so thank you for your patience. I would like to do this a lot more, which is why I stream, because I can spend time exploring these kinds of topics while people ask questions and interact, and that's what makes it very interesting for me. If I was just doing this on my own, I don't think it would be I don't think it would be as rewarding or as exciting, to be honest. So yeah, name basics. And I would like to change the music a little bit. I think I'm going to go... I think we're going to go back to some trance. How about that? That seems to be my sweet spot, is trance, or especially vocal trance. I would put on like dubstep or something, but I think it's very hard to listen to someone talk while there's dubstep playing, because a lot of it has lyrics as well. So what are we gonna do? What are we gonna do? We need to join the name basics. This name basics table has an nconst, and it has the tconsts in this known for titles. So let's work with this name basics for a bit. From NBA, National Basics Association. No, obviously it's the name basics table, but I use 3-letter aliases. So nconst, and we should split the known for titles using the comma into splits. Tconst split. Oh, that's not good. What's happening here? Just need to Google this, why that's not working. Split part. Split a given string based on a delimiter. Ah, yeah, we need to pick out the number. So this is tconst 1. So we need to figure out again what the maximum number of tconsts is, because this is just the first one they're known for. That's just the first one. So we're gonna, last time we used like we used a regex count, basically, sort of. I mean, we used a we basically used the length of one string minus the length of the other string without that particular character in it as a count. But that's a bit of a workaround. And so what I would want to do is use like regex substring. I think it's called substring. Let's see. So let's try substring here. Yeah, substr. So if we do known for titles and then comma. Oh, right. String. That's fine. Start position. Where we want to start. That's 1. And length is a positive integer that determines the number of characters you want to extract from the length of the beginning. It's optional. But how does it know? Ah, I see. We have to specify the substring, because otherwise that's why we need regex match. Yeah, you see. It all comes down to regular expression. So this is from Postgres documentation. So the source string is known for titles, and the pattern is any occurrence of a comma. So let's try basically just comma and then 2 backslashes. Oh wow, it doesn't. I had a problem making backslashes on my machine in DataGrip, and I haven't figured out yet why why that's a problem, I really can't. Yeah, I really haven't figured it out. So I need to basically copy paste a backslash. I know it's a bit silly, but it's like, I'll just put it here so I have it. So regex match, let's call this commas. Does this work? Let's find out. If this works, that we extract the commas, then we could just count them. So that doesn't work. That's weird. It's pretty weird. Because I'm fairly familiar with the regex, so we'll just do 1. What's the format for the regex? It's just a string. Okay. So there's a site I use to check regular expressions to see how they're valid. This is a good site if you need to test your regular expression. So let's bring in the known for titles here. It is, yeah, it is text. Just wondering if it wasn't a text field or something. So backslash comma. No. Oh, it's just single backslash comma. Matches the character comma literally. Yeah? Oh, there we go. But what if I want to match any number of them? Then we do occurs 1 or more times. No. Let's do the group in front of it. Count number of commas. The table-based solution is more intuitive. Oh, I see. There's actually a function called regexp split to table. That is super cool. I did not know about this. That is really cool. If this exists, then we can just do it this way. And we basically say known for titles, and then we have to say what the delimiter is. Let's call this table split. Oh wow, that's amazing. So what it's done here, just for you to understand, this value is here, the second value is here, the third value is here, fourth value is here. So now we can just, oh yeah, so now that we have this, select star from no limit. Yeah, no limit. Basically select nconst, which is the name, let's call it person, and then count distinct. Let's name this something else. Let's call this tconst. Tconst number of titles, and then we group by 1. And now we find out who has the most titles attributed to them. Now, as I said before, I assume that they've made a cap somewhere of the number of titles that they've attributed to each person, because they don't want someone to re-engineer their product, basically. Oh wow, that's intense. Just gonna forward the music a bit. Oh, I don't like this song. There we go. Wow, this query is intense. Maybe I don't need to include the known for titles. Let's do it like this. Limit. Let's limit to 100. Maybe it'll be faster. Oh wow, okay. It's capped at 4. It's capped at 4, which is that's really, really, really unfortunate. I hope it's not like that for the whole data set. I hope it runs, because I would really like to know if all of the people are attributed to 4 titles. If they are, then it's going to be very hard to figure out if they have good ratings or not, because everyone has some like arbitrary number of titles attributed to them. But we could still do the director one. Now that we have this function, which I didn't know about, this regex split to table, we could jump to doing the directors, writers have the best ratings question instead of so the question originally we wanted to look at was, does the number of actors, actresses affect the movie rating? But it looks like this is gonna take way too long to process. Let's not forget this name basics table is pretty big. Let me just show you. This entire table is 10 million rows. I don't think I said that before. It's 10 million rows. It's basically like 10 million people who are actors, actresses, writers, directors, etc. And they've already done the legwork for us. Oh, here we go. So we actually have it now. I'm totally gonna see how big this is. I assume it's 10 million. Took a minute 37. It should be around 10 million entries, because that's the number of... Yeah, I guess we don't need to do that. So we have the number of titles, and I sorted it the wrong way. If I wanted to actually re-import this 10 million, I could export it here on the right hand side. I could export the data, and then I could re-import it again as 10 million rows with the person, but I don't need the number of titles therein. So I need, at the moment, basically the question is, does the number of actresses affect the movie? I need to attribute each movie to the number of people in it. And the way that we do that is by splitting off like we did here. So we're going to keep this part of the query. I'm going to get rid of this. So that's the data frame. So we're going to call this titles. That's fine. Then we have persons. I know it would be called people, but it just seems weird to call it people. Sorry. So we have persons as nconst and then tconst. This is all the all the titles they're known for. The difference being, you see, that each person has multiple IDs that can be joined. So if I have a table now, this is really cool. If I do here, I have titles from this table. Let's just take a look at the titles table, just so you know what it looks like right now. Okay, this is my titles. I have a title with a rating. Let's bring in the primary title, because I find it a bit confusing to work with just So we have all these titles with ratings. Now we want to join. We want to do a left join, classic. We want to do a left join. So this is called, I almost wrote something else there. Let's call it TT. That's close enough to what I wanted to write. Wow, the music is, the volume's all over the place. Sorry about that. Yeah, do let me know if it's too... Oh! Ibika! Wybika? I never knew how to pronounce your name properly. I'm just gonna call you Fedorov. Welcome to the stream. Have you been lurking the whole time? So limit, we don't need that. Left join, what do we call this? Persons? PS. On ps.tconst equals tt.tconst. So what we've done is we've now linked the two together. I have my title, on the beach, 7.1. 1440p. Oh, you mean in terms of stream quality? I do have a pretty good internet connection. That is very true. I hope that you can read everything nicely and see it nicely. Let me know if it's too small. I can make it even bigger. I think there's a limit, but I'm glad you like it. So now we have, on the beach with its average rating, and then we have the people in it. So this person, nconst. I see that you're trying some commands. Unfortunately, I don't have any commands in there. I will work on doing that with Streamlabs at some point. But at the moment, seeing as I'm not affiliate status yet anyway, the real fun stuff with all the channel points isn't possible yet. So that'll happen soon enough, hopefully. Need to get my viewership up, and then I should hit the follower count at some point, and then we'll be able to do that kind of stuff. Definitely. So we have the tconst, the primary title, the rating, the average rating, and then we have this nconst, ps.nconst, which is the person. But we'll just leave it that way for now. I need to include the person's name. I don't know what it's called. Primary name. Okay. Now, what do we do with this? What do we do with this? What do we do? We want to figure out... going back to the question, does the number of actors, actresses affect the movie rating? Now, if you remember this dataset name basics, if we go back, you see that there's actor, actress, writer, actor, actress in this primary profession. I think we actually need to restrict our query because otherwise we're including everyone else who was involved in the movie. So, you can see here on the beach, Fred Astaire. We don't know if this is the actor or actress. So what we should do is make a little where condition here, where primary profession like, that's the easiest way to do it, actor, and because we have two versions, or actress. Now we should only get persons. Let's just try this briefly. Primary profession. We should only get data in this query with, oh, you see? That's why we have to test. AlphaQ Mom, what are you doing? I am currently exploring an IMDB movies dataset, and the question we are answering right now is, does the number of actors, actresses affect the movie rating? So we're basically going to plot all the movies on a chart with the rating that they had and the number of actors, actresses in it, and see if they are correlated in some way. But at the moment we are trying to filter this data set for just actors and actresses, and that didn't work. And why is that? Because I wrote it in uppercase. I capitalized it. That's why it pays to test this, because afterwards we would have not seen. Ah, you see? Here we go. So we have anyone who is actor, soundtrack producer. So some people have multiple roles. We don't know in what movie they were in what role. Where are you from, AlphaQ Mom? Are you in the stream for the first time? I don't seem to remember you from a previous stream. So, now this is correct. It's great that you're new here. My stream generally deals with data analysis, things, looking at different data sets, but I will also be doing other topics as well, like front-end data collection, debugging, things like that. You can also feel free to let me know what you'd like to see on the stream as well. I have a suggestion box on my profile. You can just pop a suggestion in there, and I'll take a look at it as well. So what we have is we have, for each person, all the titles they're known for. So all, maximum 4 it seems per person. But let's see what comes out. What I want to do is now figure out who is in what movie, which I have now. So on the beach, Fred Astaire, and for some of these I will have multiple people. I haven't ordered it yet. Let's I need to put the order by before the limit. Let's see. Oh, maybe that limit's a bit too big. So what I want to see is basically for one title. Ah, here we go. This is what I wanted. You see, now we have Bohemios, we have 2 people in the movie. The story of the Kelly gang, we have a lot of different people in the movie. Now, I don't know if this is accurate, we're just trying something out here. So what we can do is we have the T-const, the primary title, the average rating, the number of people in the movie. Basically means count distinct PS const. Number of, let's call it talent, because yeah, the actors, actresses, I don't want to write both, so let's just write talent. Group, oh boy, group by 1, 2, 3, referencing this, this, and this. Convenience factor from Postgres. So let's run through it again. Titles, people, persons. Then we join them together and we do a count for the number of talent. And then when we execute, now, who knows how long it will take, hopefully not so long, we have every single title of every single movie that has a start year, that has a rating, for only actors and actresses, we have a count of talent and the rating. Fun, fun, fun. So now, what should we do with this? I think we should put this in Metabase. So Metabase is a business intelligence tool, basically for data visualization. And I think we can put it in there. It's a big data set, but it doesn't matter. 258,000 rows, no problem. So let's switch over to Metabase. Here we go. This was our one before, where we saw the distribution. I'm going to run this query. I don't know what visualization is going to be best. Probably a combo chart. Probably. But that's only once we have the data in this frame. So we have to wait a little bit until the data is loaded. It should take the same amount of time as before, which was around 13 seconds. Barely had time to drink that time. So what I see already is some problems. Like, we have some movies with 0 talent. That is because the data set from IMDB with the names attributed to what movies is not full. It's not fully complete. That's the reason for that. So it's unfortunate, but let's see what comes out of it, okay? I don't think it's going to be very accurate, which is disappointing. So we have a combo. X-axis is going to be number of talent. Y-axis is going to be the rating. Okay. That's not really what I want. Let's see. This is combo. What's it counting here? It's definitely counting something. Hold on a second here. Sometimes when you take an existing data set and then put it in the same visualization as before, it ends up looking a bit odd. We could do a scatter, but that's just gonna look weird. That is pretty funny though, actually. Yeah, this has been truncated to 2000 rows because, yeah. You can see the error here on the right. Data truncated to 2000 rows. That's because it's not able to display everything. Whoa, Jesus. Yeah. For that, we'd have to probably summarize this into clusters of number of talent. For that, we would have to know the distributions, which I don't feel like doing again. Let me just take a look here. So combo chart. I have to see which data goes on which axis. I don't want to count them. That's the thing. So I could have here the primary title on the x-axis. There we go. The y-axis is the average rating, and now I add another series. Here we go. Oh wow, that's laggy. There we go. Number of talent. We can configure this to be probably on which axis? No. Is it possible? Ah, here we go. Right axis. And this one is left axis. Okay. Now what do we want to do? Maybe smooth them out. Can we smooth them? Very hard to see if there's a correlation like this, right? That's very hard, and it's also, I think it's not displaying some of the values. No. Ah, yeah, it is. So there's 2000 in here. Purely based from these two, purely based on this visual, maybe we should order? That might help things along. So we want to order by the average rating, which would be 3, descending. Let's see if there's any pattern visually distinguishable. Again, this will take a few seconds to execute, but it shouldn't be too long. And we are nearing the 2-hour mark, so I will be calling it a night after this one. Oh wow, okay. So there are some unique titles that have very high ratings, but there's no overlap here about number of talent and the rating. And now let's be honest, I mean, we didn't really expect that, did we? It's a bit weird here. I don't know what's happening. I don't know why these spikes are here. I mean, we would need to probably group this into different buckets, because it's very hard to see anything with the raw data. But purely from a raw data standpoint, I think the number of talent is also really skewed, because as we saw from the raw data, there's a lot of these zeros. That could be weird, because like here, average rating of 10 has 0 talent, like the top 3 here have 0 talent, so I don't think the underlying data is very good, to be honest, which is a bit disappointing. I expected a better data quality from IMDB, seeing as they did provide pretty good data set. So we're going to say number of talent as a derived metric. I'm just going to summarize this here so we have it for later as well, in case we come back to this later. Number of talent as a derived metric is inaccurate, sum 0, therefore inconclusive. I mean, if anyone does some searching afterwards and finds some literature about someone who's looked at the number of individual actors or actresses in a movie and its according rating on, you know, IMDB, Rotten Tomatoes, etc., I'd love to see that. We could definitely restrict this to one genre, but I feel like the number of talent as a metric is just inherently not very accurate. So yeah, I don't want to use that. I don't feel comfortable using it. So some of the other questions that we were looking at about number of actors and which actors have the best ratings, those won't work if you know, the derived metric is inaccurate probably because the underlying data set of this name basics is not accurate. However, what could be accurate is this title crew, where we have the directors for each title. And this could be a nice thing to close out the stream, where I'll just make the query and we see which directors have the best ratings. How about we do that? I think that sounds cool. It's basically what I wanted to know, is which directors have the best ratings, which directors have the worst ratings. So here we go again with a brand new query console. Which directors have the best worst movie ratings? I am curious to find out. I'm sure some people have some ideas, hypotheses about which which directors will have good ratings. Titanic. So, oh, again, music. Let's try like this. Oh boy. There we go. Where do we start? We start with the same data set we did here, because that was a pretty good query. And I'm just gonna go a little bit faster through this one. Do stop me or ask questions if you're a little bit lost. But it shouldn't be too complicated. So titles, we have the primary title and the rating from the basics, that's fine. Next, movie, you start year and we have a rating, fine. Then we have persons, which is no longer from name basics, it's from title crew, which means this changes to TCW. TCW. Yeah, it's easy enough to spell. We don't need this condition anymore. Oh, well, we could say where directors is not not null. I think that's right. Yep, okay. Where directors is not null. That way we have at least the data set of all the directors. So we have tconst. Oh, we needed that regex split. So this is basically, let's call this directors. Title crew. Directors is not null. Regex split to table. And this is the nconst, because it's going to be directors. Let's see what that looks like. Yeah, so that's basically the name, which is fine. Can we do the left join in here? We could try. I don't know if it works, but we could try it. I also don't know why it did that left join there. So left join IMDB dot name basics, so NBA dot nconst equals TCW dot nconst. Oh, sorry. Yeah, nconst. Oh, we won't have that available to us. That's the problem. This is a derived table. So we have to do this afterwards. My bad. That's fine. We'll just limit it to 10 for now, just to keep things... whatever, we can limit afterwards. So instead of number of talent, which we don't need anymore, we now have the left join of titles. So we start from titles. And then we have the left join of directors, ds, on ds.tconst equals tt.tconst. And so in the directors table, oh, you know, it would make sense to just join this before and then just join once at the end. Yeah, why don't we do it that way? So directors with name as select star from directors, ds, left join IMDB basics on NBA equals ds directors. So you'll notice with the aliases, something that I am doing consistently, at least, I hope, is 3-letter aliases for original tables and 2-letter aliases for derived tables like these. And that's just something I practice, and I find it much easier to work with aliases that way. It's just a personal preference. So directors, what do we need from that? We actually need tconst and the nconst. So we have tconst, nconst, ds. And then we need the nba dot primary. Oh, not that one. The other one. Primary name. That's the directors with name. We probably could have done this easier, but this is derived function. Yeah, you could do a select from with a nested thing. That would also work. But I like this, it's cleaner. Much cleaner. So we have directors with name. We're going to call this directors with name. This is now dn. So on dn.tconst is the tt.tconst, and now we just add dn dot primary name, and that is the director's name. Limit 100. Execute. Take a drink of water. There you go. So for sanity, I am going to include the ID of the director, of the person. That's my data set. So this is the final, I don't know, let's just call it final view. We add our comma up here. Oh, that was interesting. Auto formatted there. Not to my liking though, I might add. So, select star from final view. And that's the final query. And now, we have to rank. So basically we do nconst, primary name, director name, director ID, whatever. And then we do average rating. And because they could have multiple movies, we do the average of the average rating, which is the average rating. Group by 1, 2. Order by 3, descending. And who are the best directors according to IMDb? Sergei Dolbilov, Luis Bustamante, Lindsay Briggs. There's a lot of them. Actually, no, there's not that many. So perfect tens. What we have to consider is the number of films. So we do count distinct tconst, number of titles. And now we can start to box them.
You're listening to Alien Feeders.
These are not the buckets yet, but so this was not the final view. You see, it was a mistake to call it final view because it's not the final view. So these are single title directors. Single, what should we call this? Director rating. Oof, that's interesting formatting. Select star from director rating. We don't need to actually join anymore, but I just, out of best practice, I keep doing this. So what we want is the directors with name. Oh, sorry. We want the director name. We want the average rating. And we want the number of titles. We want to bound them. So, I don't know. We can figure out what the bounds are. Let's find it out first. Number of titles. Count distinct. Getting late, so I can't type anymore. Count distinct director ID. We're going to call this number of directors. Group by one. So now we get to find out what the bounds are for these, like basically the spread, right? We get to find out. Oh wow. So there's a couple of directors who have a crazy amount of titles attributed to them. Not many. So 59. And then here it starts to increase a bit. So like 30, 40 titles. These are just movies, huh? So there's some directors who have 10 plus movies. That's pretty impressive. There's the bulk, obviously, who have 1 or 2 movies, right? So that's fine. So how are we going to cluster this now? Well, we make a percentage, basically. So first we work out sum of directors, right? How do we do that? Select star from director rating. And what we do is we do basically the sum, or just the count distinct of the director ID. This will give us a number. Total directors. 112,680. What a nice number. So this is how many directors we have in our data set. Fine. So what I do now is I have number of titles, and then instead of counting the number of directors, I can do the number of directors. Then I can just do percentage of directorship. It's probably not the right word, but let's do it this way. Divided by 112,680. And I'm going to make this a float. And now we have the percentage distribution. So basically I'm going to make my bounds according to the percentages. So 62%, 15%, 7%, 4%, etc. So what I'm going to do is say 1 title, 2 titles, 3, 4, 5. Where's the drop off? Here's the drop off. 0.404% points. 00. Let's graph this. I want to see where the actual drop-off is. So we're gonna just pop over to Metabase quickly before we wrap this up for today. If you've enjoyed today's stream, let me know in the chat. Would love to have your feedback. Suggestions, there's a suggestion box in my profile for things to improve about the stream or topics you'd like to see for next time. I'm very open to those things. I've got a couple ideas and things for the next upcoming streams, but I can rejig things around. It's not an issue. So visualization area, maybe. Number of titles. Wow, that didn't work. Wow. Why is this not working? That's weird. Okay. Let's try bar. Number of titles. Wow. Okay. Try the other way around then. Ooh, there's... Great. All the other values are illegible. Because the number of titles... Okay. There's like a huge stack there. Let's do like this. Okay. So logarithmically speaking, at around... We're looking for that sort of Nike sign now. We could do it the other way around too, right? We could do... Personally, I would want the number of titles on the x-axis and the percentage on the y-axis. Just my preference. So I'm gonna make the y-axis gonna make logarithmic, because that's what's calculated, the percentage. Let's try power. That may be a bit clearer to see. Yeah, so it's around this sort of 30 mark that things get a bit weird. Histogram. That's the easiest. That's, to be honest, that's the easiest to see. And that's basically here. That's where that hic happens. Between 3, 4, 5. I would say 5 or greater is already in the minority. So we're going to do 1 title, 2 title, 3 titles, 4 titles, and 5 or more. And there's obviously some people out here with 2,000 titles, but that's the way it is. So what do I mean by that? I mean that we are going to basically do case when, which is one of my favorite things, honestly. One of my favorite functions. When number of titles equals 1, then single director. Let's just call it single. When number of titles equals 2, then double. When number of titles equals 3, then triple. Oh baby, a triple! Don't know if you guys know that one. Then quadruple. And then when number of titles equals 5, then... Okay, equal to greater than 5. Then 5 or more. And this is what we are going to use to determine popularity among directors. Because these bounds Oh, we have to, sorry, I got confused here. Else unknown, and director level, let's call it. So we have the director level, the director ID. Actually, that should be up front. Just like, you know, formatting pains. So we have director ID, the director level.
Future sound as voted by you. The list
Thank you, Future Sound.
Future sound.
Then we have the average rating and the number of titles, which we don't need the number of titles anymore, but we need their name. So, director name. Ooh, why is it not completing? That's odd. Okay, director name, average rating, number of titles is no longer necessary. So director ID, name, rating, and this we're going to call buckets as. Put a comma in here, and we are basically done. Start from. So I'm rushing a little bit, just because it's getting a little bit late, and I want to finish this. Oh, wrong format. Cannot be used in an aggregate, of course. Group by 1, 2, 3, 4. Yeah. Whew. So now we have every director with this classification of whether they are single director, blah blah blah. So what we do is we take a window function. That's an easy one. The window function can be copied from our previous query. From the 40? No. Was this one. Just copying it from a previous function query from yesterday. Basically, it's called rank. So we're going to rank every director based on their bucket. So we make a ranking. The ranking is, let's close this. So we have everything from the buckets, and then we do rank over partition by. This is how to divide. Oh, we need to clean up a little bit. I can see there's a bit of an issue here with these director ID. So that's the directors with name, where directors is not null, and director ID, so that's nconst. Oh, directors is not equal to \n, basically. Because that seems wrong. Then they can be joined. From ranking. Oh yeah, it doesn't like this, sorry. So partition by, that's what is our window going to be? And our window is this director level. That's like how to divide each of the directors. And we are going to order them by average rating. So each director is going to get a rating. This is what it looks like. Each director is going to get a ranking, sorry, not a rating. So we have director ID, director name, average rating 1, director level double, percentage of directorship, which is no longer so interesting for us, but this is the, let's call this director rank. So this is the in the doubles, this is the lowest, right? So we have to do descending to get the top ones. And we can do the same thing to get the lowest ones. Like this. So director rank. Dusan Nestorovic in the doubles. And basically, because we have now each director with each rank, we can do the easiest thing, which is select director name. Let's do director level. Blah blah blah. Director name. Average rating. And what we do is that we then say where director rank top equals 1 or director rank bottom equals 1. So basically, are they on the top or are they on the bottom? And normally we should get a list of, well, we had how many levels? We had 5 levels, 24 rows. So we have a couple ties as well. So let's do this. Order by 1 and 3 descending. Oh right, we should maybe name these. Oh, actually, you know how we could name these? We could just do 1, 2, 3. This might make it easier. 4, and then 5 plus. That's why I'm not doing integers here. That's why I've put them in single quotes. Let's see if this works. So we have a couple of ties. There we go. Single movies. Oh, there's quite a few ties in there. 2 movies, no tie. But it's only taking... Oh, right. Sorry. My bad. I need to sort both of them differently. So this one's descending, this one's ascending. And now we should have the top and bottom directors for each category. So these are tied for the top with 10, and these are tied for the bottom with 1. We should probably like consider the number of votes or something as a factor, but we didn't do that. But we should probably do that. But basically, the best director with 1 movie are all these people. And the best director with multiple movies, so 2 movies, is Dusan Nestorovic. 3 movies is Zlato Topčić. 4 it's Menios Karagiannis. And 5 plus is Umberto Baccolo. And I don't know who these directors are, by the way. If you know who they are, feel free to to put in some more information in the chat. We can actually add the director's ID, and you can actually search for it on IMDB. So if we do director ID, I wouldn't actually mind figuring out who this is. Umberto Baccolo. Oh right, I added a field here. So that would be correct now. And I'll just take this ID and see if I can put this director in there. Let me just bring this up. Should be able to show this. So, what you can do is you can just put in the ID in IMDB, and it actually gives you the result. So this is Umberto Baccolo, blah blah blah, known for not that many movies. Oh wow, okay, yeah, there's quite a few. Documentary, 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 short documentaries, shorts. Wow, okay. That's quite a few. That's quite a few. This is very, very interesting. Also an actor, apparently. So this is pretty cool. Pretty cool. I didn't know that that would be the result. But yeah, that is quite cool. So that's what we did today. It took a lot longer to do some of the things I wanted to do. Some things weren't possible, which were a bit disappointing. But I hope we could answer that. We can say varies by number of titles attributed to them. But yeah, I mean, we'd have to probably take the number of votes as a factor. We could get that in from here. Title ratings has TRA number of votes. And what you do is you just keep carrying it through. So directors, that's fine. Directors with name. Final view. So you would open this up and have the TT dot number of votes. Sharp Claw, well. We have found out who are the worst and best directors on IMDB. Have you been lurking the whole time? Did you go back to a stream? I'd love to raid you, but don't have enough viewers for that probably. But thank you for the raid earlier, that was great. Hope they enjoyed seeing something else as well. So we keep carrying this number of votes through. You can just take it into each of these ones. Like here, average rating, number of titles. You can just put it in here. Sum, number of votes. Then you just say sum of votes. And you can, this is the nice thing about common table expressions. You can just keep adding it progressively because you know you've built them synchronously. So you say here, sum votes. Then you add your group by here, like that. And then in the ranking, at the bottom here, you do the sum votes here. And then we could figure out, okay, is there an issue with the votes? Is there some kind of manipulation going on? Or is it only based on one vote? We could discard them, you see? Look at this. Almost no votes. You see? So these are more significant because there's 300 votes. Here, 300 votes, right? So the ones that have less than 10 votes, for example, we could exclude them now. And we could make our data set a little bit more clean, right? So we do the OR condition. We're just going to wrap that in brackets. And then we say sum votes is greater than 10. Voila. And then this list should be much shorter. The moment it was 98 rows. Now it's 31. Very interesting. Oh, these are also... we should probably look for ones with like 50 votes or something. Not very significant, as they would say. So this one has... Gökhan has 37,000 votes. That's impressive. Okay. Very interesting. So I hope you've seen something interesting today. We didn't look at directors in relation to generations, release years of movies. We didn't look in relation to genres either. I'm sure there's a huge difference between genres, directors of each genre as well. My visualization options are a little bit limited, even with Metabase. So I would want to have better understanding of something like R, for example, to be able, and ggplot to do some really cool plots, to be able to show more complex relationships as well. But that's something coming for another time.
For the future sound, go to facebook.com/alienfeeler and
So I think that's a great way to end the stream. If you have feedback or anything you'd like to say, let me know in chat. And otherwise, I wish you great rest of the week. If it's evening where you are, good evening. If it's morning where you are, have a great day. And if it's in the middle of the night, you should probably be sleeping and not watching my stream. Although if it helps you fall asleep, that's also fine too. So thank you for watching, for being here, and look forward to seeing you next time. I should be online again, I would say this week. Mondays is usually pretty certain. But yeah, it all depends. The second stream of the week all depends on how things go with work. So maybe it'll be closer to the end of the week again. Might even be on the weekend, like we did last Saturday. So thank you and have a good night.